We're looking at factoring a perfect square trinomial and a difference of squares, part 2. Let's start looking at some examples that deal with perfect square trinomials now. Let's move this away, and let's keep those two, the pattern for recognizing perfect square trinomials. Let's keep it right here as a reference, and let's look at this example: x squared minus 8x plus 16. Okay. So first, as I mentioned before, when I look at a quadratic equation, I don't know whether it's a perfect square trinomial or not, right? I normally try to follow those steps in the flowchart, which is basically try to get a common factor among all three terms. No, is this a simple trinomial or a complex trinomial? It's a simple trinomial. It's a simple trinomial. Now, before I go ahead and use the simple trinomial steps, which will give me the correct answer in any case, let's see if I can use a faster way, and that would be recognizing this pattern. Well, this looks like a perfect square, and this looks like a perfect square. So this could be a perfect square. The middle term is key to this. The middle term is the one that will reveal whether this is a perfect square trinomial or not. So let's collect our data here. Let's do some investigation, right? A is equal to, well, if this is x squared, then a would be x. B would be what? Well, b is 16, right? So we expect, if it's a perfect square trinomial, we suspect that it will be this pattern because there's a minus here, right? The second one. So let's look at 16, okay? 4, right? Now let's investigate this. 2ab, right? Which would be the middle term. This is our middle term. Let's see if we get that, right? So a is 1x, so let's put this here, x, in fact 2, right? So let's write down the 2, right, times a, which is 1x, right? I don't need to write the 1x, times b, which is the 4. Now for now, let's just forget about the minus and let's just concentrate on the 2ab part, right? So 2 times x times 4 gives us 8x. So this 8x matches this term, so we know that this is a perfect square trinomial. So we can use the patterns that we have recognized here to more easily and quickly solve quadratic expressions, right? So we know that our a value is going to be x, our b value will be 4, right? And then we put a minus here because we know it belongs to this pattern, and then of course we write a square there. Alright, let's look at another example, and by the way, for this one I invite you to try it out without using perfect squares. Just use the normal simple trinomial square and you'll see that you would get the same answer as well. Alright, let's look at another example here, and we're going to keep this one as well as a reference. And that is 4x squared minus 12xy plus 9y squared. Once again, right, I notice that this is a perfect square, and I notice that this is a perfect square. Now this term will reveal to us what this expression is a perfect square trinomial. Let's do some investigation. Now I chose this example because we have two variables here, but in the same idea, right? We consider it as part of the term when we are squaring it. So let's do some investigation. This will clarify things. So 4x squared would be, when we square root that, we would get 2x. Okay. B would be 9y squared. We would get 3y, right? For the b squared term. We suspect it's going to be the second one. So now let's do some analysis, some investigation here. Well, we have 2ab. 2ab will be equal to 2 times 2x times 3y, right? So 2 times 2, 4, times 2 times 3, 12, right? 2 times 2, 4 times 3, 12. X times y, xy, right? And so this 12xy matches here, right, and there's a minus, so then all we have to do is the following, right? Once we recognize a perfect square trinomial, right, we do this. We know we're gonna have 2x, we know we're gonna have 3y there, there's a minus, and then we square it, and we are done. Of course, I'm taking all these steps at the beginning, but once you start recognizing these, you might not even have the need to write all this, right?